In this lecture, we will implement the object container actor that can be used as some sort of inventory slot. First, we have to create the actor itself. I will just call it object container. Let's open it. And now we're gonna have to add two spheres, static mesh and the collision sphere. Let's start with the static mesh. Here, let's set this to 0.2. Compile. And for it, we will completely disable the collision. And we're gonna have to add the sphere collision that can be used for detecting the interaction. Both should be attached to the root component. Let's set the radius to 10, so both spheres would have more or less the same radius. Now, because we want to see the object we place inside, let's create a transparent material for it. I will just call it like that. Let's open it. Here, click on the output and select the translucent as blending mode and unlit as the shading mode. Now type const 3 or 4, then right click, convert to parameter, and we'll name it color. This will determine the color of our sphere. In our case, let's set it to blue. And just connect it to the emissive output. Again right clicked, now just constant, again convert to the parameter, and let's call it opacity. This will determine how transparent we want the sphere to be. And connect it to the opacity. And that's all, pretty simple material. Now let's apply it to our sphere over here. Right, so now we'll be able to see the object we place inside. Now inside the object container actor, let's create two variables. First gonna be the reference to the actor that was placed inside. The second gonna be the array of grab components that are currently tracked by this sphere collision. So they will represent the grab components that can potentially belong to the object that can be placed inside. We will track all of them, and especially we will track the grab release event. That's how we will detect where we should place the object inside or remove it. Now select the sphere collision component. Here make sure that you have generate overlap events and the correct collision profile set up, and click on these two for begin overlap and for the end overlap. These events we're going to use to track when some actors started or ended overlapping with ourselves. And for all actors that are currently overlapping, we will add all his grab components to our list and will detect their events when they're grabbed or released. Let's start with begin overlap. Here we will get all the components of type grab component and we'll have to iterate over them. First, we're gonna add the grab component to our list, and then we're gonna need to bind some custom events of ourselves to the grab components on grabbed and on dropped event dispatchers. So first on grabbed and on dropped. Now let's create the custom events we want to fire when the component is grabbed. I'll name it onTracked component grabbed, and the same for dropped, gonna be onTracked component dropped. Alright, now we're gonna create two helper functions, try capture object and try drop object. Let's start with this one. It will take a grab component as an input. The owner of this grab component, that actor, we will try then to place inside our object container and try drop object. Here we will take exactly the actor object reference as an input. So potentially this should be an actor that equals to the one we are currently have placed inside the object container. Let's first implement the capture. So here first we're gonna get the owner, so exactly the actor that we potentially can place inside the object container. Here we will have to set the owner of the grab component, the actor, to our held actor variable. The only thing we call these functions with a try prefix because we assume that they may fail due to some circumstances. So for example, we will check if the held actor, so the one we have placed, is not valid. Only then we can try to place something new. Otherwise, it's impossible, so we will do nothing. Now about the placement itself. So first of all, because we want the object to just sit inside and not fall, we will have to disable the physics for it. We're gonna just use the grab components function for it. And after that, we will just attach our new potential target, which is currently considered as the real target, to the root component of ours. Now, for the location rule, we use snap to target. For the rotation, I propose you to use keep world and here keep world. So the keep world for the rotation will allow us to place the object in the same direction we were holding it. It will allow us to do things like, for example, holster for a weapon. You can use snap to target if you wish to. Now for the dropping, we will first have to check if our current held actor is valid or not, because if it's not, we won't have to drop anything. And then we will check if it equals to the one we're passing here as a parameter. We need this check because we will be calling this function from any potential grab component that we were tracking, but not all of those could belong to the actor that is currently placed inside. Then we will have to check whether the held actor is still attached to us. This is important because, for example, if the object was grabbed at this moment, it can be attached to something else, for example, to a hand. And in this case, we should not trigger the detachment logic, otherwise we will try to detach it from the hand, which is undesirable. So in case its attached parent equals to ourselves, only then we will continue with detachment. For detachment, we're gonna just get the reference to held actor and call detach from actor, with all three rules set to keep world. Let's connect it here, and for both cases over here, for whether this is true or false, in the end we're gonna have to clear our held actor variable. We're gonna have to just set our held actor variable here to nothing, which means that the object was successfully grabbed by someone from this object container. Now let's use those functions. Here let's get the owner actor, and because that's the case when some object was grabbed, we will try to drop it. And when some object was dropped, we're gonna try to capture it. Both of these events will fire only for those grab component object owners who are currently overlapping with us. So we have subscribed to them on begin overlap. Now on end overlap, we're gonna have to unsubscribe from those. But first, we're gonna have to try dropping the object. This can be the case when the object was not grabbed directly, but was, for example, remotely pulled from us. Now again, we're gonna have to iterate over all the grab components of the actor that stopped overlapping with us. Then we will just remove the element, so the potential grab component, from our list. And we're gonna have to unsubscribe from both of those events we subscribed to earlier. So if the object was pulled away or just stopped overlapping with us, we no longer care whether it was dropped or released, it's not of our concern. Here you have to connect it like this. Just make sure you're connecting the right events. And now for onGrabbed, connect it here and connect the event over here. The last thing here, because we want some sort of visual feedback when we can potentially place an object, we will implement a simple size change for the sphere, so visually it will be a little bigger when we are overlapping it with some potential target, and it will be reduced in size when there's no object overlap in it. We're gonna do this on tick, and we're gonna check whether this array is not empty and whether this actor is not valid. You can use these two and then just type not boolean. So this is the case when we have potential grab components overlapping ourselves, but we have no actor placed inside. That's when we will increase the size of the sphere to show that, hey, you can potentially place something. And here you can use select on the vector, and we're gonna just add our desired sizes for the sphere for both cases. And then we're gonna need to get our static mesh component and set world scale 3D. Now let's just connect all the pins. All right, so this object container can be used as being placed in the world or attached to our pawn as an inventory slot. For example, we can just drop it like this into the world, and it's gonna be a real working object slot. Later, it's gonna work like this. Now let's try to add the object container as an inventory slot to our VR pawn. For this, we're gonna use the child actor component. It allows us to create an actor of any type, and then it's being attached to us. So here we will specify the object container as a type. Now there can be different ways how you might want to attach it, but because right now the only thing we have is a camera, I want it to be relative to a camera to some extent. Let's create a simple function called update inventory, where we will take care of its position. Here we will first get the world location of a camera, then with a little offset up, and we'll use the right vector of the pawn to then shift the slot a little bit also to the right. For the distances, let's just make a literal float here. You can convert it to a parameter if you want to, and we'll use the multiply node. So this will shift our slot a little bit to the right. And now let's do the same for moving the object up. Here, let's use the multiply, but split struct spin and apply it only to z value. Now let's add the result. And then we're gonna get our child actor component and set its world location using these shifted coordinates. And hit teleport because we don't want it to interfere with anything. It most likely wouldn't, but still it's better to do it. And we'll call this function on tick. With all this implemented, the slot won't be just attached to the pawn, but will be shifting constantly to some comfortable location according to the player viewpoint. So the player will be comfortable with placing objects because the slot is always somewhere nearby. Here let's select negative value, so we will shift the slot down, not up. And let's try to test. Let's pull something, for example a gun. Here we have our slot we released and it's placed over there. We still can shoot. It's exactly positioned so we are like putting our gun to a holster. You see the rotation is preserved. We can also do the same with the slot placed just in the world. And so far, looks like we have successfully implemented the object container.